Hi everyone, my name is Jijun Wang. This is my DSAI project for BPE 1201. I did a home electricity audit in my apartment in Minneapolis to see how much energy my everyday device actually use. Here is my outline for my presentation. uh, Background and energy context, audit process, qualify my projects, what did I learn? I currently live in an apartment still residence in Minneapolis, Minnesota. Our unit is 1,115 square feet, and there are 3 people live there, including me. On November 1, our apartment was charged $90.40 for electricity. If I convert this use about for 60 cents per kilowatt hour for Minnesota, that is about 190 kilowatt per month. So I will use 119 kilowatt per month as the baseline for my audit and compare my device to the number. In the apartment, most of electricity I can control is plug-in device. I choose it to measure. On my here, laptop charge, desk lamp, keto, rice cook, Wi-Fi, road, phone charge, and microwave off. They are actually the kind of device the assignment asked us to measure. I use a plug-in power meter to measure every device and to take a photo of meter together with my University of Minnesota ID card. This shows that I actually did measurement myself and did not just take picture from the internet. This is my daily log, and this is my measure pictures. For constant power device, the calculate is very simple. Daily kilowatt equals on watt times hours on plus of watts times hours of and divide by 1000. Except my Wi-Fi route was 50.2 watt and on 24 hours a day. It is 40.7 watt my times 24 and divided by 1000 equal 0.35 kilowatts per day. For variable power device, I use the kilowatt model on my meter. First, I let it run for time. I normally use it that I did measure kilowatt per divide measures hours to get the average water. Finally, I multiplied by my daily use from the log. Example, my computer was 0.064 kilowatt in 3.4 hours. About 21 watts, I use it 1.1 hours a day. so it equals 0.02 kilowatts a day. For the cycle device, the formula is daily kilowatts equal kilowatts per cycle times cycle per day. Example, rice cook. Um, example, my rice cook was 0.192 kilowatts per cycle times 0.771 equals 0.50 kilowatts a day. For lights, I didn't need the meter, I just used the waters on the bulb and multiplied by hours I turned it on. Daily kilowatts equal bulb's waters times hours on divided by 1000. Example, 8 watt times 2.5 hours divided by 1000 equal 0.2 kilowatts a day. What did I learn? After I put eight device into spreadsheet, the auto calculation total equals 0.78 kilowatts per, which equals about 23.5 kilowatts per hour. So this is the amount of energy I can directly expand from the depth I measured. For the data, I noticed that one always on depth can be the biggest. My Wi-Fi was used alone was 0.35 kilowatts a day. I also noticed that some devices like the lab or phone charger are small, but because I use them almost every day, they still appear in the total. Compared to the apartment average, now compared to the real numbers, my 8 hours device equals 23.5 kilowatts a month. My November bill equals about 190 kilowatts a month, and the ELA data for Midwest apartments is much higher than that. So my 8 device do not explain all the electricity. This means some energy is used by the building or by other appearance I didn't measure. Compared to online average, when I compared my measures to online average, Wi-Fi lose 15.7 watts inside the common 5 to 20 watts range. Laptop and phone charge average also match online value when they are actually charged. My homemade field was only 2.5 watt, which is lower than the 10 to 35 watts main size. So I properly measured it in set by model. This shows I understand why my number can be a little different. Because I have numbers, I can see how much I can save. 10 Wi-Fi of 8 hours at night, 3 to 4 kilowatts per month. 10 homer of when not needed can save 2 kilowatts per month. Cook rice a bit less often. 1 to 2 kilowatts per month. Together that is about 7 to 8 kilowatts per month, which is around 30% of the plug-in loss I measured. This is my reference. Thank you, everyone.